wanted to take the time today to walk through the Pear Deck review with you and go through all of the correct answers to the slides. So let's just go back and start with slide number 1 and work our way through. If you remember from our conversations in class, and probably going back for several years in science, anything that has mass and takes up space is called matter. Anything that has mass, takes up space, is called matter. This next slide is basically asking us the difference between how you find the density of a regularly shaped object, something that for which there is a formula, and an irregularly shaped object. So what it comes down to is how you find the volume, because we know that the density is going to be the mass divided by the volume. We'd find the mass using a balance, but it's the volume that would be a little bit different. So if it is a rectangular prism, if it is a cube, if it's a pyramid, something like that, you basically are going to use a formula to get the volume, and then you would use your density equals mass divided by volume formula to calculate the density. If it is an irregularly shaped object, we're still going to do the density equals mass divided by volume, but in this case, in order to get the volume, we're going to use water displacement to get the volume. So the difference basically is that for an irregularly shaped object, you will use water displacement to get the volume. For a rectangular prism, you will use a formula to get the volume. But in both cases, you will still use density equals mass divided by volume. Next one, I believe, is a multiple choice. What holds atoms together in a molecule? And what holds atoms together in a molecule is going to be a chemical bond. H2O, CO2, C6, H12O6 are all examples of chemical, and again, this is water, carbon dioxide, and sugar. Those are all examples of chemical formulas. A change that produces one or more new substances is called a physical change. A change that produces one or more new substances is a physical change. Remember that in a physical change, nothing new is created. However, in a chemical change, you get new substances created. So this statement would be false. Soil, a salad, and sugar water are all examples of, these are all types of mixtures. They're not the same type of mixture. So soil and salad would be a heterogeneous mixture. Sugar water would be a homogeneous mixture because you can't sort of differentiate the individual parts. How are these two things different? We have an endothermic reaction. We have an exothermic reaction. So if you remember, in an endothermic reaction, what happens to heat? Heat is absorbed. And in an exothermic reaction, heat is given off. So endothermic, endo means it enters or comes into, heat is absorbed. Exothermic, exo meaning it exits or it leaves, heat is given off. The volume of an irregular object can be measured by, and we just did this one a moment ago. For this, we would use water displacement. we would use water displacement in order to find the volume of an irregularly shaped object. I'm looking to make sure that that's the correct one. All right, how do liquid water, ice, and water vapor differ from each other? Well, they're all water, they're all H2O. The difference is that they are different states of matter. They are different states of matter or different phases of matter. A substance is a single kind of matter that has a specific composition. That is the definition of a pure substance. It is a single kind of matter that has a specific composition. So the answer is true. All right, now you're using a chart. How does the density of liquid water compare with the density of ice? So let's go over here and look. The density of liquid water is 1.0. The density of ice is 0.9. So how do they compare? We would say that liquid water is more dense than ice. This is a multiple choice. I need to look at the test to see what your choices were. One example of a physical change is, and I think your options were burning paper, baking cookies, toasting marshmallows, or dissolving salt in water. And the answer is dissolving salt in water. That is a physical change. When you dissolve salt in water, nothing new is created. This again is just a definition. The ability to do work or cause change describes energy. The ability to do work or cause change describes energy. How might we know if something is a mixture or a compound? How might we know if something is a mixture or a compound? The difference being, let's see if I can type all this out. A compound, let me go back and type this. The parts of a compound are chemically combined. So the parts of a compound are chemically combined. The H is chemically combined to the O to make H2O, to make the compound water. Just a mixture, your carrots are not chemically combined to your lettuce in order to make your salad. So the parts of a mixture are not chemically combined, but compounds are. Again, here's another multiple choice. Let me see what your choices were. One example of a chemical change is, your choices were filtering a mixture, burning wood, boiling water, or crushing a can. The only one of those that creates a new substance is burning wood. The smallest particle of an element is called an atom. By definition, that is true. Fireworks exploding in the sky and giving off light are an example of, again, since it's giving off light and heat, since it's exiting or leaving the firework, then it is an exothermic change. Hardness, texture, color, and freezing point are all examples of what types of properties of matter? Those are all examples of physical properties of matter. if a sample of silver and lead each had volumes equal to 1 cubic centimeter, which sample would have the greater mass? What would the difference in the masses be? All right, so if we do the math on this, you would have to draw your density triangle. And if you drew your density triangle, you would see that you're trying to find mass. So mass would be D times V. And since our volume is 1, just the mass then is going to be our answer. So now let me just kind of work through that. So if we do our density triangle, we know it's M dV. We're wanting to find mass, so we cover that up. So we know that mass equals D times V. So if we are doing that for, let's see, lead. So lead, the density is 11.3, so it's 11.3 times 1, which is 11.3 grams. If we do this for, what was the other one? It's silver. Silver is 10.5 times 1 equals 10.5 grams. So which one would have the greater mass? Lead has the greater mass. And how much greater is it? 11.3 minus 10.5. Lead is 0.8 grams greater. All right. Next one. A blank is a group of 2 or more atoms that are held together by chemical bonds. Let me look. Is this a multiple choice for you? A blank is a group of atoms that are held together. Here we go. By, it's not. This was a fill in the blank. And I believe you have a word. I can't remember on the test if it's going to be fill in the blank or multiple choice. But the answer for this is a molecule. So a molecule is a group of 2 or more atoms that are held together by chemical bonds. To find the mass of a rectangular object, you multiply the object's length times width times height. Alrighty, you find the mass of any object by using a balance. Length times width times height is what will give us the formula. Therefore, this statement is false. All right, we have another problem using this same chart. And it says a 54-gram sample of an unknown material has a volume equal to 20 cubic centimeters. Based on its density, could the sample be aluminum? And explain your answer. All right, so let's draw up here our density triangle. We know that MdV, we know this is the mass. We know that this is the volume. Based on its density, so we're looking over here, could it be aluminum? So we're trying to find if this object could be aluminum. So we need to calculate to see if the density comes up to that. So we are doing mass divided by volume. So density equals, the mass is 54 grams divided by its volume, which is 20 cubic centimeters. If you do the math, then you find that it is 54 divided by 20 is 2.7 grams per cubic centimeter. So yes, it can be aluminum. To explain your answer, anything that is 2.7 grams per cubic centimeter can be aluminum since that's its density. Doesn't matter the size, doesn't matter the shape. It's always going to have that density. The fact that matter is not created or destroyed in any chemical or physical change is called by definition, that is the law of conservation of mass. It is the law of conservation of mass. A blank is formed when two or more substances are so evenly mixed that you can't see the different parts. So this is going back to the different types of mixture. So we know it's a mixture. This one would be, since you cannot make out the individual parts, it is a homogeneous mixture. A heterogeneous mixture, you would be able to pick out the individual parts, like a pile of rocks or a salad with all of its different parts, a bunch of toys in a toy box. How could you find out whether or not an unknown liquid is water? So from all of our work, we know that liquid water is always 1 gram per milliliter, or 1 gram per cubic centimeter. So you would calculate its density to see if it is 1 gram per milliliter. So you just do mass divided by volume of the unknown liquid. You calculate its density. You see if it is 1. If it's 1, then it is water. If it's less than 1, it's not. If it's more than 1, it's not. So you would not want to taste it or drink it or something like that, because it may not be water. It may be something that you're not supposed to be drinking. A volume of 25 milliliters is the same as a volume of how many cubic centimeters? So if we remember, milliliters and cubic centimeters are the same thing. So the answer would be 25. So milliliters, cubic centimeters are the same thing. A substance that undergoes a chemical change is still the same substance after the change. Since that is an underlined word, we need to change it to make it true. So a substance that undergoes a chemical change is the same substance. That statement is false. It would be a substance that undergoes a physical change is still the same substance after the change. And it looks like that brings us to the end of your Pear Deck review. I will also post the takeaway after I close the session on Pear Deck. That will be in Google Classroom. So you can go back and look at your answers, what you chose for your answers to all of these, and compare those to the correct answers here so that you can prepare for your test. And again, your Chapter 1 test will be basically these questions. It will be available on Canvas tomorrow. So good luck studying for your test. I think you're ready for it. Have a great rest of your day.